3 o'clock, so welcome back to the third panel session in our day today looking at standardization and the commercial space industry. In this panel, we're going to hear NGO, academic, and other perspectives. So I will turn it over now to Jim Armour. Jim, the floor is yours.
All right. Thank you, Jim and Joe, for inviting me to participate in this forum. And thanks, ANSI, for setting up and assembling some really terrific panels. I've been very pleased listening so far. For those of you who don't know me, I'm Jim Armour, retired Director of Government Relations for Space at Northrop Grumman, where I did all the licensing for on-orbit servicing, as well as 35 years in the Air Force before that. And I have to admit, I'm a little bit sad to not be there when as it converts over to the U.S. Space Force. The opening comments by Colonel Scraps Hernandez were a very good review of the space policy directives and a reminder that actually we've made some excellent progress in the last decade on policies for space. George Neal's government panel was also a reminder of the importance of taking those policies and converting them into regulations that follow through. Encouragingly, I heard a great deal of continuity in the departments and agencies, and so I have hope, regardless of the administration changes, that we are going to continue to make good progress. Teresa Jones' industry panel, again, is a reminder of the excitement that's going on in commercial industry, the speed and innovation that we're experiencing, and hopefully that these standard-setting processes will encourage, but that a lot of challenges remain. And this panel, our panel, is going to look at third-party perspectives by non-governmental organizations, academia, and professional organizations at standardization in SSA, STM, and orbital debris mitigation. So I'm just going to introduce our panelists one at a time and invite them to comment, starting with Dan Oltrogge, who is the Director of the Center for Space Standards and Innovation. But he's also, and I'm going to list these off, Director of Integrated Operations and Space Policy Expert at the Commercial Space Operations Center. He's also the Program Manager of the Space Data Center for the Space Data Association. He's the founder and administrator of the Space Safety Coalition, which was referred to earlier in the panels, and is the U.S. Head of Delegation for ISO TC20 Subcommittee 14 Space Systems and Operations, for which ANSI is the Secretariat, I might add. So, Dan, looking forward to hearing you.
Yes, thank you very much. Thanks to both Jims here and ANSI for inviting me to participate in this cross-country and I think very interesting and more importantly, timely discussion of standards and STCM. As Jim mentioned, I am wearing a lot of hats that are relevant to this discussion. I apologize for them, but I think this area is very, very important. So that's why I'm trying to do everything I can to work in the many different areas to move us forward. As Jim mentioned, I'm the administrator of the industry-led Space Safety Coalition. The SSC, which was formed just over a year ago, serves as a critical function of assembling commercial best practices that operators can use to aspire to higher standards than consensus international guidelines or minimum regulatory mandates. The SSC set of best practices firstly adopts and strives to promote and implement the industry consensus guidelines and standards that we already have, building upon that with an additional set of over 40 best practices. And second, as Jim mentioned, I am the lead U.S. representative and developer of international standards under ISO Subcommittee 14 for Technical Committee 20. I also participate with ANSI in those standards and CCSDS standards development. I'll note that I am currently leading the development of standards like the orbit data message and co-leading the conjunction data message enhancements And as Kevin mentioned, Kevin O'Connell mentioned this morning, we're also working to establish new standards for both space traffic coordination and management and large constellations. Third, I also want to say I'm the Director of Integrated Operations and Research at COMSPOC Corporation, and I really, really appreciated the last panel. I thought they addressed a lot of important points, and I share many of those points with them. I do want to say that there's the notable exception is that in the space traffic coordination and management demonstration we just completed a month and a half ago, I guess, it clearly showed the need for comprehensive data fusion and advanced analytics, and that fusion needs to be at the raw observational level to get actionable products. I want to point out space actors, relevant to some of the comments from this morning, space actors have a legacy of underestimating the risk of and from space debris. In the early days, we deployed numerous bits of debris as either experiments or left derelict deployment mechanisms such as cables and canisters and platforms, upper stages and spacecraft. The mass numbers that J.C. Liu mentioned this morning are huge. And we didn't appreciate how those actions would adversely affect the space environment in the long haul. Now, as we're entering the new space era with launching many, many satellites and launch vehicles, in my mind, we're kind of into a grand experiment here, because I think we need to acknowledge that there's a lot that we know that we don't know. And for example, we've got many, many large constellations. Well, how many are actually going to be viable and launched? What's the marketplace going to be for those large constellations? To what extent is better design and manufacturing, testing and quality control going to map to reliable, robust spacecraft? How will appropriate orbit selection be handled to translate to space sustainability? How responsible will large constellation operators be? How effective might AI and machine learning be in disposing of collision risk? And finally, how effective will active debris removal by companies such as Astroscale that was on the last panel be? So in the face of such a grand experiment, I think it's vital we understand that space debris issues are much easier to understand before the fragmentation events occur. If there's only one takeaway from what I say today, it needs to be that space safety must be based on SSA data that is sufficiently timely, accurate, and comprehensive to meet the needs of how we're using it in the operational construct. And I'm here to tell you, we're not there yet. The rapid innovations of commercial industry, represented by safety-conscious space operators, commercial SSA providers such as COMSPOC that I work for, and Leo Labs and EXO, and active debris removal companies such as Astroscale, must be integral to this picture. And I think the Space Safety Coalition that I represent and its best practices provide a pathway for enabling the partnership that's needed. Thank you for the opportunity, and I look forward to your questions.
Okay, thanks, Dan, for that. Our next panelist is Professor Danielle Wood. I believe I saw you on the line earlier, Danielle. She's an assistant professor in media arts and sciences with a joint appointment in the Department of Astronautics and Aeronautics at MIT. Within the MIT Media Lab, Professor Wood leads the Space-Enabled Research Group, which seeks to advance justice using systems designed and enabled by space, which is pretty inspirational to me, Danielle. There she co-leads a team developing the Space Sustainability Rating, and I had a chance to participate briefly in that earlier, in a consortium that includes the World Economic Forum, ESA, UT Austin, and Bryce Space and Technology. She is a scholar of societal development, and in her research designs innovative systems that harness space technology to address development challenges around the world. Prior to this, Professor Wood held positions at NASA headquarters, NASA Goddard, Aerospace Corporation, Johns Hopkins University, and the United Nations Office of Outer Space Affairs, and I am definitely looking forward to what you have to say, Danielle.
Thank you so much, Jim. Are you hearing me loud and clear?
Loud and clear.
Perfect. It's really a pleasure to join today's discussion. I have to just reflect, it's the end of the academic semester. So today I have just finished a closing day of class. And the class that I teach literally takes all the topics you just heard and asks, can we indeed advance justice in Earth's complex systems using designs enabled by space? And several students took quite proactive and future-looking research topics for their class presentations, which are actually relevant to today. So I think we see a good preparation for future space policy analysts. One was asking questions around how we'll consider issues of celebrating heritage and monuments on places like the moon and beyond. Another was doing a study of commercialization, particularly of lunar material and the process that we might see in the next couple of years, asking what will be the process by which we determine by example what the world wants to do in terms of identifying whether we consider it okay to buy and sell materials from space. And so these are ongoing and sort of today's discussions. I'm proud of the students who are involved.
Danielle, can you hear me?
Yeah, I can't. Can you hear me, Jim?
I can hear you. Apparently audio has gone out for some folks. Not quite sure what's going on there.
Yeah.
Jim, this is Dan. My audio failed. I had to restart and then got back in. So I
yeah,
think that's what happened.
Too. Mine did too. There's some way we can get her attention.
Danielle, we lost your audio.
Is that connection still working?
We can hear you now, yeah.
Now.
Yeah, we can hear you now. We lost probably 45 or 50 seconds.
Okay, Danielle. Great to know. I was trying to see what was happening. I'll go back a few sentences. Thank you.
Thank you.
All right. So I wanted to just give some background onto the development process of the Space Sustainability Rating, and I was highlighting the World Economic Forum through their Global Future Council on Space held a competitive process to select a design team. And so this has included MIT, University of Texas at Austin, Professor Morbajan in particular, including also the European Space Agency's organization, which is their Space Debris Office, as well as we're working closely with Price Space and Technology. So this team has worked very closely together, and of course, many people have given us advice and input along the way. And we've come to a great milestone now where we've actually been able to finish our first draft of defining what the components of a space sustainability rating should be, and particularly focusing on aspects that have to do with what happens during the operation of a satellite, both during the design, the orbital operations, as well as what happens at the end of life. So we're particularly looking at topics such as how does an organization participate in collision avoidance and data sharing, how do they participate in meeting international standards, and how do they participate in activities that in the future especially may draw upon the benefits of commercial services or ability to deorbit through systems if it's needed. We also ask the question how difficult it is to track missions on Earth, from the Earth, missions that are in space. So all those are technical components that can be evaluated through objectively stated questions. So we're going through a process soon, which will include a process to do beta testing to understand with particular satellite operators who have volunteered to help us evaluate whether our questions make sense and whether they can be answered in a reasonable way. And that will lead us to a process also to select a long-term organization that can play a role as the operator of the space sustainability rating. In fact, we've just, even today actually, are receiving letters of intent from organizations that are interested in operating the SSR. And we're moving through the process in early 2021 to review that and to identify an organization or a consortium of organizations. I'd love to answer questions about the next steps. I don't want to overstep my 5 minutes, so allow me to pass the mic back over, but so excited about the progress we're making with the space sustainability rating. Thank you.
Great. Thank you, Danielle. Our next panelist is Dr. Ruth Stilwell. Are you still with us, Ruth?
I am.
Excellent, excellent. Ruth is the Executive Director of Aerospace Policy Solutions, LLC, an adjunct professor at Norwich University and senior non-resident scholar at the Space Policy Institute at GWU. She's one of the leading authorities on integrated space and aviation policy and governance, and recently played a key role on the ICAO Air Navigation Commission in the development and approval of global standards for aviation, very relevant. Her current work focuses on space traffic management, the integration of commercial space launch and civil airspace, and the development of cooperative traffic management for aviation and space operation, which I've had a chance to work on in the COMSPOC, among other things. So she's a contributing author in a lot of reference books, and I will turn the mic over to you, Ruth.
Thanks, Jim, and thank you to ANSI for convening this meeting and inviting me to the panel. I appreciate the update, particularly from the government panel. It's been very useful in getting a sense of where the U.S. is on rulemaking standards, and it's important work to continue the U.S. leadership role in space. I have to step back for a second and say I'm very jealous of Danielle because Norwich University starts on a quarter process, so today was actually the first day of our term, and we just launched a capstone class. I have a new batch of students. When it comes to space traffic management, there is discussion about whether it's the right term, but I'd argue that it captures three key elements. One, the prevention of collisions between objects when one or more have the ability to maneuver. Two, the prevention of increased collision risk by mitigating the number of non-maneuverable objects added to the orbital domain. And three, the removal of existing high-risk objects in space. I'd like to take this moment to emphasize the need to be outward-looking in this process, because this is an international concern, and it cannot be solved by the U.S. alone. It is precisely because of the international nature of space that complicates U.S. efforts, even within the confines of the U.S., because requirements that are perceived as too strict could drive industry to other states of launch. This is why it's critical to focus on safety as the basis for any regulation. There is a shared interest between states, operators, insurers, and militaries to maintain the long-term safety of the orbital domain. At the same time, the potential value of the orbital economy makes it clear that safety cannot and should not be maintained solely through an attempt to restrict future access. The focus needs to be on safely expanding the capacity of the orbital domain, and this expansion comes through standards, regulation, and technology. I think it's obvious from today that there's a common belief that international agreement on standards is necessary, but it's important to recognize that this is not just a commercial problem. As we heard from the panel, the military use of space is an important priority. It needs to be kept in mind in the process. When it comes to international agreement in particular, the process for civil standards and best best practices is very different than the levers available when it comes to military use. This isn't unique to space, but it's important to recognize the difference. As we go down the path, philosophically, we could adopt different sets of standards for military and civil use. But in doing so, things get very muddy very quickly, because this line between a civil operation and a military one is blurry. Not every country breaks on the same lines. So what is military to one is civil to another. Civil-military cooperation itself within the states varies widely from country to country. Even something as ubiquitous as GPS. It's a constellation that is a military asset, but its civil applications are clear. So in trying to develop standards in silos, commercial here, military here, civil over there, we might actually make the problem worse. Trying to divide the question, working just on those commercial standards, even if just for expedience, may not get us where we need to be. So when we talk about a whole of government approach, it needs to include space for the reality of its military use. The activities to develop standards need to consider the limitations that are imposed by the diplomatic constraints of developing best practices that ideally would apply to all actors in space. If we want a comprehensive solution, we need to be cognizant of the fact that certain agreements will not be reached because states will not give up sovereignty in that regard. There are models that we can effectively use, and I would argue that ICAO is a very good one in how they address the civil use of aviation, recognizing a widespread military use as well. So it's important to ask the first question. Where is agreement possible given the existing constraints? And where, well, more specifically, between whom are agreements possible? What needs to be at the COPE-US absolute consensus level, and what can be achieved through multilateral diplomacy? For example, can major spacefaring states reach an agreement on kinetic anti-satellite testing? If it's unrealistic to ban the activities, are standards possible? Instead of don't blow up your satellite, can we reach an agreement that in the event of a debris-producing ASAT mission, they need to be conducted in a manner that X% of the debris will deorbit within X period of time? Are those standards that we can reach so we understand what is accepted behavior in the global community? Colonel Hernandez made a key point. Standards provide us with the opportunity to distinguish between benign activity and a potentially hostile act. This is important, not just in a military construct. As new technologies and operational concepts emerge, things may not always look as they seem. On-orbit servicing may look a lot like a hostile act to everyone except for the two parties that contracted for the service. How do non-participating actors know that they are observing a benign activity? So as we talk about standards, it's common to look at the technical side of the equation, but I would argue that our most important first step on the situational awareness side of the equation in particular is a requirement for transparency. A few other panelists have mentioned this, particularly with regard to intent. This goes back to the question of where agreement is possible that moves us forward. What information are parties willing to share? Can we begin that process at a high level and push it down over time rather than trying to get everything on the front end? Looking at the 21 guidelines for the long-term sustainability of outer space activities, we find provide, improve, promote. These are aspirational terms. How do we move from the aspirational to the operational? What are the steps? How can the work of standards organizations like ANSI and ISO evolve into international agreements? Voluntary industry consensus standards and UN guidelines based on absolute consensus are a starting point. But when you're working from a consensus base, you tend to get a bit vague for an actionable operational standard. We need to recognize that that is just a start, but there needs to be triggering mechanisms to turn this work into action. So I hope that we can have a discussion about that portion of the topic. Thank you for listening, and I'll be here for questions. Thanks, Jim.
Great, Ruth. That was excellent. So I'm going to move on to Marlon Sorge now. Marlon is a principal engineer for the Space Innovation Directorate of the Aerospace Corporation, which I have a lot of experience with. They've bailed me out of many, many problems during my life. For more than 30 years, Sorge has supported an incredibly wide variety of space debris and space situational awareness related projects, as well as strategic planning, conceptual design, technology development programs, and astrodynamic analyses. He organized Aerospace's debris research program, where he developed the aerospace fragmentation model and conducted some of the first work in real-time fragmentation event risk assessment. He's also the DoD representative on the NASA delegation to the IADC, where he supports mitigation guideline and standard development. Marlon, looking forward to hearing the status from you.
Great. Thanks, Jim, and to the other Jim and ANSI for putting all this together. I think having these discussions is absolutely critical, especially now. I want to also thank Ruth for the great lead-in with the discussions on the importance of focusing on safety. I wanted to start off by making the point that with the areas that we're looking at right here, traffic coordination and management, orbital debris mitigation, and the associated SSA and SDA that make all those things possible, those are all ultimately related to safety issues. Which makes them a little different than a lot of other categories of standards, which are put together to help things function together more efficiently. In the case of the areas we're looking at here, we've also got that safety aspect where it isn't just trying to make things work better, but you're trying to be able to keep them working at all. So that's a critical thing to remember as we're going into the discussions. Now, well, anybody really in the industry at all knows clearly space operations are changing right now a lot, very quickly. There's all sorts of new stuff that's going on. We're seeing huge increases in the number of operational satellites, the size of constellations, and in the opposite direction, how small satellites you can build that still perform very functional services. There are entirely new forms of operation like on-orbit servicing and active debris removal. And there are even whole new regions of space that are now getting used that weren't used before. And all these changes are bringing an enormous amount of potential opportunities. It's just really exciting to see all of that happen. But of course, as is always the case, they bring challenges and risks. And I think one of the things that's key for all of us in the standards community to think about is how do we find the balance between enabling those opportunities and mitigating those challenges and risks. And I think that's absolutely critical in this area that we figure that out. But it puts a lot of pressure on standards, best practice, guideline development in order to be able to do that. One of the things, and I've heard this discussed several times today so far, is whatever rules of the road we come up with, we need everyone to be following them. If there's anything true about space, maybe more so than anywhere else, is that what one group does can affect everybody else very quickly and very easily. Another thing that's been changing recently, of course, is the amount of emphasis in space activity that's commercial. It's a large percentage of what's going on in space is now commercial. And there are some different constraints that commercial organizations have over, say, just the government. For example, having a bottom line. And, it's critical that we take that into account, both in terms of the fact that we're going into a world where there's all sorts of different, more complex space operations happening, and we have that added set of financial constraints on top of it that potentially can lower the margins of operation for a lot of missions. Because of that, one of the things we need to consider with standards is that they are very well justified. We're not putting standards together because they make us feel good. They make us feel like we're doing something. They need to justifiably be performing a function, helping advance the goals we have for safe space operations, so that we know that the costs that are associated with them are going to be justified. And another thing we need to do clearly is we need to be very, very flexible in the type of standards we develop. As I was discussing before, we have a huge range of operational satellites now, for example, from the very small to the very large. We have an enormous range of missions, from single satellites to ones that have potentially constellations of thousands. We need to be able to figure out how to design our rules, our guidelines, our standards in order to accommodate all that, because it isn't just that we have big and little, we have everything in between as well. And as keeps coming up, and I don't know how many times I've seen this over the last few hours, the speed of change is really a driver here. Things are moving much faster than has ever happened in the past. I mean, think about how many things have happened in the last few years in space that you would have never thought would have been possible before, or that would have happened. You know, satellites that are going up to do the maneuvering for other satellites, or landing first stages so that they can be reused again. And you know, we've traditionally in the guidelines standards area had a lot of time to develop standards to figure out how to get things right, and we're increasingly losing that. We're getting more and more behind, and so we need to be developing these standards in a way that is flexible enough that lets us be able to keep up with the speed that change is going on. So you put all these together, and we've definitely got our work cut out for us. And that's the reason for one of the big benefits of having discussions like this is so we can work these things out and figure out the path forward. So I thank you for the time to talk, and I am looking forward to our discussions.
Great. Thank you, Marlon. I'm going to wait. I had a little bit of an echo here. Okay, it went away. Our last expert panelist is Fred Slane. Fred is the Executive Director of Space Infrastructure Foundation, which he founded in 2003. And he's a leader in the development of space standards in the U.S. and abroad. In the AIAA, he serves on the Standards Executive Council and is the chair of the Committee on Standards for Space Plug and Play there. He's a member of the ASTM standardization effort on spaceflight safety qualification. Internationally, he works, as do some of the others, with the ISO Subcommittee for Space Systems and Operations, ISO TC20 SC14, where he is the former U.S. head of delegation. And today he serves as the lead architect and chair of the Interfaces Integration and Test Working Group. He's been the project lead on 14 ISO and AIAA space standards, has published over 15 papers and reports, and has presented numerous classes and presentations. And we will ask him for his presentation now. Fred?
Thanks, Jim.
You're welcome.
And thanks, Jim, the other Jim. I chose to address the issues today in the same order that that Jim McCabe gave us in establishing the agenda. So what I'd like to do is basically start with a question, or answering a question, if you will, on what are these policy instruments we're talking about, and what is the purpose of a best practice or a standard? I want to start from those points because they're key for us. The policy, and in my view, is something you set forward so that you can control or guide the relevant group. And the purpose of a best practice or a standard is to state a measurable baseline agreed upon by those with a direct and material interest. So I'd like to compliment Jim McCabe on the construction of the panels, because we actually in the three panels have the normal, if you will, grouping of those with direct and material interest. We have government, we have industry, and we have academia and others. So that's a pretty well established thing, and Jim, I'm sure you did that on purpose, but not everyone realizes it. So 2 points then. Implied but required is a balance in, as standard development organization in a project membership. You have to have industry, you have to have government, you have to have academia, you have to have others, you have to have an open forum for those with a direct and material interest. And that means you have to let a lot of people in the door. It also helps us in making sure that we don't have people in our technical discussions who are, well, I used to say UFO chasers, but I don't know anymore. That might be a whole new thing that we need to consider. The reason we're gathered in this forum is because of industry growth. I want to make sure that we're really clear on that. we're addressing a need to adjust policy and best practices and standards in anticipation of this huge growth over the next 10 years. If that wasn't there, we wouldn't be having this discussion. And so it's important then to understand what growth means. So growth for us is not a simple number. You can have a lot of new programs and throw a whole lot of money at building new things, but if you don't grow capability, which generates profit, not just revenue, generates profit over time, that's an important aspect of growth. A couple of derivations from that. So growth is not reinventing what we already know. Costs on programs where standards are not used but are available cannot be accounted for as part of growth. Policy instruments are needed to constrain spending on programs which do not use existing appropriate standards or leverage and grow the standards base. I see that as a challenge for parts of the industry from decades past. Policy instruments are needed to encourage spending, including commercial investment, on programs which do use existing and appropriate standards or leverage or grow the standards base. So we are led to which standards enable growth for the commercial space industry, and I think that's part of our questions part of our question base that we're trying to address. And I think it has to do with optimizing growth in a commercial context, new capability, that is, which generates profit. And we have policy and best practices that benefit the broadest commercial return, maximizing space opportunities. Well, what does that mean? What's another way of saying that? If you have views and concerns and different perspectives that you need to bring together in a particular domain to construct what that domain is going to do, we call that an architecture. And it's been said that if you have the elements of an architecture, even if you don't have an architecture, you have an architecture. So I think what we're talking about here is finding a way to minimize the architecture risk for as many space opportunities as possible. Of note at this time, architectures that are going forward are things like confers, OADR. An example of something that failed in the past but had the right idea was the SUMO project, collaborative effort between the NRO, SMC, and NASA. That had the right idea and basically, well, we could talk about that at a different time. So we want to, I believe, concentrate on standards development for core architectural elements. And I think that what we're trying to do is have an open architecture, that is, the rules of the architecture are well understood and commonly shared, not the specifics of the implementation. That, of course, can be proprietary. But, and then enforce existing policies across the U.S. government space agencies. They must participate in the development of the architecture and the standards that support it. I think that's a policy statement that is actually policy, but I do not believe it is adhered to across the board. And so that's something that we can work on. I believe we need to identify what that core space architecture and space architectures are, identifying the open standards that support that. And today we're talking about space traffic management and SSA and debris, but there are other components of that as well. And then one of the things to do then is make sure that our core space architecture is open, scalable, and extensible. So with those thoughts, I will step back and welcome questions.
Okay. Thank you, Fred. So I would invite anybody to write in the chat or raise your hand. I don't see how to do the raise the hand function here, but I'm sure Jim McCabe will help me out. In the chat function, list your questions, and I'm going to start out with a question to Dan to get it going. Given the diverse set of standards development organizations, many of which you're on, Do you have concerns about the likely disparity between standards that result and which standards might become enforceable under U.S. regulations?
Yes, Jim, thanks for the question. It is, I think, really on point. At the risk of stirring some passionate discourse here, I want to assert that I think the U.S. is in a bit of a standards free-for-all presently. I have had concerns over the duplication of standards. And as Marlon said just moments ago, we need everyone to follow the same rules. And that becomes difficult if we haven't achieved a harmonization amongst the standards we have. So while I think multiple SDOs or standards development organizations are making great work assembling relevant standards, in my opinion, what may be missing is the government adopting particular standards that it chooses to embrace in particular subject areas. We've all heard the terms flags of convenience. I think Ruth alluded to that earlier. We're a country who may not have a rigorous space laws and doesn't actively promote space sustainability and best practice, may be selected because it's easier, cheaper, or more expeditious to use them. I was all set to coin a phrase for this particular panel of standards of convenience. But as it turns out, this is already applied to reindeer meat affected by Chernobyl, believe it or not. But the point is, if you've got multiple standards out there, then the users of standards can choose the ones that best fit their needs, but maybe that's not in the best interest of the FCC and FAA and NASA and Space Force that use them. So I would say a lack of U.S. subscription to particular space standards across our civil, commercial, and government branches can lead to standards of convenience. Over.
Okay, great. There was a question asked about space sustainability rating that we've been having sort of in the chat session, and I want to invite Danielle to sort of bring it forward in the conversation here. The question was, reliability has been a critical design attribute for satellites, yet they, of course, still fail. How will the space sustainability rating inform designers and manufacturers design and build better space systems? Could you elaborate on that verbally a little bit, Danielle, for the rest of the audience?
Thank you so much, Jim. And I appreciate the comments and the ideas because it gives me a chance to give some further concrete examples. Because, of course, part of discussing the space sustainability rating is there's a lot of content we could focus on, so this gives a nice way to focus. And I think I just want to make sure you can all hear me now, right? Perfect. I'll try to keep an eye on the chat. But this is great because I think part of what we hope to do is really be creative. Part of the reality of the space sustainability rating is that we hope it applies to different kinds of missions. So, of course, you can imagine one category of mission, university leaders, people thinking about small companies, and they're going to focus not necessarily on reliability, but on proofs of concept or demonstrating what they can do with large constellations sometimes. You have other categories of missions that are operated by governments, and they really are ensuring that they're going to have science or another kind of mission operating for decades to come. So they have different goals. So, of course, if we ask the question, can we optimize around reliability, that wouldn't necessarily be the same for these different kinds of operators. So we acknowledge that. So instead, we ask the question, given that there's different kinds of satellite operators who have quite different mission objectives, we don't want to be here in the business of sort of evaluating which objectives are more valuable. We just want to say, everyone should aim for safety. Our goal is to give as many options as possible during the development phase, the operations phase, and end-of-life phase. So we can take those three categories for now. We could ask the question, when you're pre-launch and you're deciding things like the actual orbital location you'll choose, and you have some information about the history of that orbit, how can an operator consider the constraints of physics and see what mission they're trying to achieve, but also ask if they can choose locations where if they did have failures and concerns about reliability, they could try to make choices that would allow them to be less of a risk for collisions and for debris creation based on the orbit they're choosing. That's one example. There's also the question what kind of materials and even features they can put into the satellite. Some of this is looking more toward the future. For now, we know that there's not a lot of demonstrated and sort of data-based or evidence-based information around the idea of using on-board sort of materials and features that make it easier to track or easier to service. So that will be more important in the future. So the question of when you're planning the design of your mission, of course, there's already a good tradition of questions of making it easier for lasers to observe you, for example, or considering how your particular radar cross-section will be depending on how you orient the satellite. So all these are choices that are made before launch. And you can think about both materials, colors, shapes, and even, profiles from the point of view of the Earth to say, can I design something that's easier to track even when it's failed? And of course, going forward, there'll be people proposing, as you see from discussions currently around space servicing, proposing things like having grappling hooks or other kinds of tools that make it easier to generically be serviced by some unknown service that we haven't necessarily seen yet, but that will be coming in the future. These are things that we're not currently giving heavy credit for because they're not demonstrated with evidence yet, but as they become more relevant, the question of what you do before you launch is key. It's also a question of what you do during the operational period. And of course, this also has to do with data sharing and participation in collision avoidance. So since, again, there's different kinds of satellites with different strengths and weaknesses in terms of reliability, the other question for us is what kind of effort is the operator putting in to the process of participating in both data sharing and coordination for collision avoidance. And of course, again, we acknowledge that different kinds of satellite operators, some universities, some small companies, some big companies, some countries, they have different capabilities for participating in collision avoidance coordination. But of course, we want to give credit for the effort they're making, and of course, if they're able to participate in voluntary networks, such as the Space Data Association, and make an effort to care about how these are run and to participate in the process of asking how do we benefit from these services, all of that's worth considering, what groups can do to be a part of the solution. There's also the physics-based question of asking how are they sharing information and how good of information do they have. And I think we're looking forward to see how commercial organizations who play a role in helping with space situational awareness will bring new options even for those space operators who do not have internal capacity to have high-quality knowledge of their own location. But if they're able to participate with commercial teams to help them with that, it's exciting. And the final piece is really about that end of life. And of course, this is tricky too, right? Because there's a question, maybe you're at year 10 and you'd planned for 10 years, but you think we could probably get another 5 years out of this mission. It's a very common question, especially for science missions. And of course, science is wonderful and important. There's always going to be the question of, does the satellite plan to get deorbited while it's still healthy and, probably could be benefiting with science or with profit potentially. And so you ask the question of if a mission chooses to deorbit, sort of on time in order to be safer, that's one direction they could go. They might also be choosing to remain on orbit but have a better plan or an updated plan for how to still be safe in the midst of extending their life. These are important and obviously very internally driven questions, so they have an impact on the external community. So all of these are things that would play into the space sustainability rating, and they're all actions taken at the pre-launch, post-launch, or potentially end-of-life phase. So hopefully that gives some concrete examples.
Sure. Thanks, Danielle. I think, Fred, did you have a follow-up question for Danielle real quick?
Yes, Danielle, when we talk about reliability, I think one of the things that we are challenged by is that we don't necessarily have a common language. I'm not talking about English or French or Russian, talking about the terms we use to describe reliability and have that as a common base. And so is that part of what you're putting into this consideration on sustainability, the sustainability rating?
To be honest, I would say we're not heavily trying to define a certain normative definition of reliability, but I do take your point. And what strikes me is that as a designer of satellites, I would start to say, well, I don't think that we expect to have the same definition in general because some missions are driven by individual satellite performance and some are driven by group performance. So this is one of the fun aspects of small satellites. You might say, well, we want low reliability for one mission so we can have, or one individual satellite, but it brings higher reliability over the group. And that's been, part of the exciting innovation recently. I think we actually are diverging rather than converging in that sense. But of course, the question might be, do you see a need for a certain, whether it's terminology or figures of merit that we at least could use to describe across communities? Is that what you're calling for?
Yes.
Yeah. So I'd say I will not claim the space sustainability rating is doing that, but I certainly do think that the communities that kind of think about how do we think about both smaller, sort of lower cost satellites that follow what's often called the lean method, for example. I think of Professor Mengucho coming out of Kyushu Institute of Technology in Japan. There are those who are trying to better match, because one of the great challenges actually of system engineering with smaller satellites can be that we need to continue to collect the data to describe how does the input in terms of like testing and the kind of design effort we put in relate to the output in terms of the reliability or the quality of the mission for one satellite, also for the groups of satellites. I think it's an ongoing, continued process where operators of small satellites are still organizing the information to have that information available, but it's moving forward. I think there are those who, not just myself, but others who have even deeper expertise in that. So I think it's happening, but it's not finished totally, but it's definitely progressing.
So I'm going to go to the next question, if Ruth will answer it. Ruth, if you're still on, I'm going to pretend like I'm one of your brand new students today, and I'm going to point out that the 21 guidelines for long-term sustainability of space, which took years to come to consensus through the UN Office of Outer Space Affairs, that work's been done now. So what else do we need to do? I mean, it's done. All we need is some transparency, right?
We do need transparency, and that is an important step forward, but it's not the sum total of the work. And I think this ties into all the things we've been talking about. If you read the long-term sustainability guidelines, which I always have next to me when I'm giving a talk like this, they provide the latitude to do the things we've just been talking about, where there can be multiple standards used by multiple actors, and that they can diverge instead of converge. So the flexibility that gets written into, I would argue, almost any consensus document creates ambiguity that we have to address. So the long-term sustainability guidelines are important because they're principles that we agree on, but they don't give us that operational, actionable piece of information. They ask governments to do things, but other than this broad construct of what the governments will do, how they do it is very much up to the underlying states. So you mentioned transparency. I'm a big fan of transparency because a voluntary consensus standard is either impossible to achieve or of very little value when you finally get it. And I know that this is not what the standards making world wants to hear. But if it is both consensus and voluntary, one of two things happen. Either you work very, very hard to reach agreement on a very soft standard that people still might not comply with, or the parties agree to a standard that they have no intention of complying with because it's beyond what they believe is acceptable. So I believe that you should either be voluntary or consensus, but not both, because both put you in a situation where you will spend years and years and years and years and years agreeing to something that does not get implemented. However, you have to mitigate for something either not being voluntary or not being consensus, and the way you can mitigate for that is through a standard of transparency. So, for example, if we look at say, ANSI and ISO came up with different standards, both safe standards, but not the same. Knowing that a space object from one country is using one standard and the other is using another is important, because from a safety standpoint, if you understand which standard is being applied, you can react appropriately. The risk in the safety equation is when you don't know which standard is being applied and you're either having to guess or assume that it's neither. So transparency is a critically important step in moving forward, particularly early on a standards process, where you may have significant hesitation to agree to a standard. If you cannot get agreement on what we're going to do, can you get agreement that we will share that information with each other so that we know what the other actors are going to do in the airspace? And when it comes to the civil-military balance, often that's as far as you can get. So the long-term sustainability guidelines are most important and most valuable because they represent an agreement that there is a problem for which action is necessary. The next step from those guidelines is, what are we going to do to trigger that action now that we have all agreed that it is necessary? Does that answer your question?
Yes, it will have to do, and I'm going to actually pass the question off to Marlon. With the caveats that Ruth has just levied on us, what do you think are the different approaches that we may need when moving forward in developing best practices and standards, especially for SSA and space traffic management and debris?
Thanks, Jim. And this, certainly from when I was talking earlier, and then if you look, for example, at some of the things that Danielle was discussing about the wide range of different kinds of operators we have, the different goals that are going on, and the fact that all of these activities are happening faster, we kind of need to look at our approach to developing standards, particularly ones that are going to actually get applied, that people are going to actually use to better accommodate what's going on in sort of this new world. One of them clearly is trying to deal with the just increasingly broad range of what constitutes space activities. I mentioned a little of that earlier. You're looking at now satellites that are, chipset type things that you could hold easily in the palm of your hand, that you could hide there, to the more conventional gigantic satellites, small constellations, large constellations, a huge range of stuff that we need to be able to cover with whatever standards it is that we've developed. This whole problem with the speed that change is happening. And I know certainly from all the different efforts I've been involved in with standards development, with guidelines, with rules of the road, with best practices, these days you always feel like you're behind because of the speed of things are going. And one of the things that it emphasizes is this need that we really need to be moving toward more prescriptive type rules, telling you sort of what needs to be done in the bigger sense, not how it needs to be done. Because if we stick to the old, well, you need to do X, you need to do Y, 2-3 years down the road, it's going to be obsolete. There's going to be new ways to do it, and we're never, as a standards community, going to be able to keep up with what's going on. So I think kind of making that change is going to be critical. The problem, of course, is like with everything, it comes at a cost. Understanding what that means, what it means to be compliant, what your options are, is more complicated, and it requires more effort. I think again, this is something that Danielle and her group can certainly attest to, is trying to capture some of these ideas is at a higher level is a non-trivial thing.
Okay. Thanks, Marlon. I'm going to move back to Fred. Ruth brought up a good distinction between voluntary and consensus. You've worked, and actually Kevin O'Connell mentioned CONFERS this morning in his talk, which is a industry association looking for voluntary rules. Could you comment on your experience with industry associations in developing standards, Fred?
Yeah. So I think we need to kind of parse voluntary consensus standards just a little bit. Voluntary in the context of most standards, those that have not necessarily been adopted as regulatory, means that compliance is going to be between parties that agree to use it. So generally, we're talking about contracts. If Party A and Party B agree to use ISO 24330 for on-orbit servicing, they have a language that they've established they've set a base for discussions in a number of technical areas that they can then work out and use some common language. The consensus part is, consensus is not unanimity. Consensus is hearing all sides of a discussion and then agreeing to go forward with the set of requirements. Not everybody has to agree to all the requirements. You just have to have a process where everyone gets to be heard. And again, if compliance is between those who choose to comply and those standards are tailorable, then, and most open standards are, open being voluntary consensus, then that's the environment you're working with in setting a standard, setting the table for the discussion, and making sure that as you move forward in the construction that you don't throw people out who disagree with the general context, but they know that they have a place where they can be heard. So I don't know if I want to push that idea a little bit further. Voluntary compliance standards have a special placed in U.S. law through the agreement between NIST and ANSI with regards to government compliance, when applicable, with voluntary compliance standards that have been developed. So I don't agree with Ruth's point, but I think that she and I could discuss this and probably arrive at some kind of common understanding of where we are.
A voluntary and consensus way of agreeing on the standards then. Dan, did you want to comment on this issue?
Yeah, actually, I'd love to. Ruth, I think, very eloquently stated the need to have standards that are either consensus or voluntary, and I agree with the need for that. I disagree that voluntary consensus standards are not of use because, in fact, the Space Safety Coalition's voluntary consensus standards amongst a subset of like-minded operators and companies, I think, is of extreme use. And that has helped inform the U.S. government even on interpreting, how to implement long-term sustainability guidelines. So I think that's very important. But you are actually saying something that I was trying to less eloquently say earlier, which is that on the regulatory front, we need standards that have measurable, verifiable, contractually suitable language that can be incorporated into our country's regulatory and operational frameworks. And we should have clarity on that. We should have a single interpretation that our country has, and other countries can interpret differently, but at least in our country, I think there should be some consistency. Thanks.
If I could chime in, Jim.
Please do.
I agree with both, and that's the interesting thing. I think this highlights a bit of the discussion we've had in the community that terms mean different things in different environments. So when I talk about this question of voluntary consensus standards in the context of the long-term sustainability, that's within the COPE-US concept of absolute consensus. It's different than when you're talking about an industry standard and process where the participants in the process have reached those agreements. When we're asking for a global international agreement enforceable by governments, this is a very different construct when we talk about consensus and voluntary. And this is where I fall back always to transparency is a very effective tool that we should not ignore, because transparency is a tool that allows the different countries to have different standards that are applied to work in an international environment because we know what that standard is. It's when we don't know what standard that's being applied that we compromise the safety of the collective environment. So I think that we actually aren't in disagreement. We are looking at the same issue from different perspectives and how it's enabled from different environments depending on who is developing the standard and for what purpose.
Okay, great. Well, we're sort of grinding down to the halt here. So I'm going to keep you on the hook here, Ruth, and see if you have any closing comments or any other points you want to make sure we make before we depart.
I'll give my first comment. When I was at the World Space Forum in Vienna a year and a half ago, I was asked, what is the biggest risk to the work that you're doing? And I think the biggest risk we have is that we will all agree and still it will not get done. So my great concern is that many hardworking, diligent people are producing a lot of work without a clear mechanism on how to operationalize those outputs.
Thank you, Ruth. Dan?
I would say ditto, first off. Well said. I share that concern that we talk and talk and talk, and I think the information is out there, but we lack action. I would also like to plant the seed, though, that our country's segmented regulatory bodies and swim lanes we have defined for each of them tend to bifurcate rules and governance, or they can. And I think we need to start thinking about not just space traffic coordination and management, but also look to, air traffic maritime, and high E, which is the high altitude airships, and launch collision avoidance, which are, we analyze, and how that integrates with the whole space picture, and look at this bigger perspective. Eventually, we have to get there, I think. Over.
Great, thanks, Dan. Danielle, your closing comments, and maybe connect it up with how space sustainability relates to the broader definition of sustainability on Earth, which I feel that you are passionate about.
That's a great introduction. Thank you, Jim. And I'll make a few closing comments. The first is just for planning. I hope you can keep an eye on your emails and calendars, and that early in 2021 you can join the Space Sustainability Rating Design community as we give updates and highlight our progress with this process of doing beta testing and continuing to refine based on input from actual operators of satellites. So please look out for that. But even more broadly, I really appreciate this comment, and Ruth, you sent chills down my spine with this idea that, of course, it's a cautionary note for us to say we must take the good ideas that we have and implement them. And as I think about that, often my community as students and researchers were asking, what kind of future do we want to leave to next generations, including in space, both in orbit around the Earth, also in places like the cislunar environment where we're going to have more activities. And I really appreciate this angle that, of course, it's easy to talk just about non-human-based satellites as a category of operations in space. But very soon we'll need to do even further coordination across the human-operated, the non-human operated, within low Earth orbit and then beyond, right? So we have to start asking and almost preparing ourselves for that which is not yet obviously technically feasible, and try, if possible, to actually organize the kinds of policies and things that are needed before the actual demonstrations are happening. It's been happening as a great tradition, actually, throughout the space era. I really appreciate the early writers of tools like the treaties, like the Aerospace Treaty. They did a good job trying to be open to a future with quite surprising technology. So let's keep that tradition going and start to ask, since technology is moving so fast, how can we really anticipate things that are not even in our present vision yet, but we know we need to get ready for them? Thank you.
Thank you, Danielle. Marlon, what have we forgotten?
Oh gosh, if I knew, we wouldn't have forgotten it. I got to say, I agree, definitely agree with Dan and Ruth about this whole issue of just, we do need to get moving. Clearly there's a lot that needs to get done in this area, and we are going to be way better off if we can get ahead of the problem rather than having to build up significant issues with things like space debris and then have to try to dig our way out of them later on. And we've seen with this discussion, and I think all the way through the day, there are just a whole range of challenges that we need to address, from some of the technical issues to, as Ruth was discussing, the policy, the practical, the organizational issues. How do you actually make things happen? But certainly from my experience, and I'm sure everybody else has been working it here, the way you figure those out is you dive in and you do something. So that's where I'd like to leave it. Is we are all here. We need to get ourselves moving.
Fantastic. I'm glad there's no passion involved in any of this, any of you. I'm gonna give Fred sort of the closing words, but I'm gonna ask him on behalf of the professors on our panel here a little bit about STEM and planting the seeds for the next generation to take on this challenge. So why, Fred, did you choose space standards development as your profession? Did we lose Fred?
Yeah, I'm here. Jim, I'm happy to say that I retired out of the original U.S. Space Command in 2001, almost 20 years ago. And I started to get involved in some of the standards development work that was ongoing at the time. We saw a need at U.S. Space for some of that to go forward, and we're trying to work with the components to make that happen. There are people who are not familiar with the standards process who were, let's say, not following the right way to move ahead and make progress. And so out of frustration, after having worked in a few different organizations, out of frustration of always being told, we can't do that, we're going to do this instead, when we knew of a better pathway to go forward, Guy Spitali, Kent Tabisca, and myself got together and said, you know, we need to find a way to be able to raise funds for subject matter experts to go to standards meetings on pertinent questions, and we need to do that in a way that stops others from telling us we can't do it. So nonprofit, we're not motivated by making money. The board of directors controls the organization. It's not owned by any individual. And there isn't anybody to tell us no. So we can go ahead and talk about things that we feel are important. And so that's the answer to that one. It was an answer of passion, going back to your other point. But my closing remarks here are that, you know, there are approximately 500 technical standards that exist today in the voluntary consensus library. Most of those are communications, but some are systems and operations, including debris, and we're starting to see space traffic management. We have multiple countries, about 13 or 15, depending on your count, involved in these discussions. We have well-populated meetings. The answer for anyone who is concerned about any of these things, and I'm talking about, you know, those with a direct and material interest, is to become involved. As Marlon said, get involved in those discussions now. Don't wait. We need to move ahead, and the responsibility sits in the lap of those with concerns. So
okay,
that's my piece. I'm sticking to it.
Well, we will make that our last word for the panel, and I will give the mic back to Jim McCabe, and he can bring it home.
Well, thanks very much. Thanks, Jim, and all of our panelists. Much appreciated. A terrific discussion. Thanks to all the attendees who have participated, especially those of you who've been here from the beginning of the day. I know it's a long day, a lot of content. This is supposed to be open discussion, next steps, and wrap up. Well, the last thing I want to do is hear myself talk. What I thought we would do, and we do have some panelists in addition to those on the panel just completed who've stuck around from earlier in the day. But we want to give an opportunity for any of the attendees who might want to weigh in with anything that you think we've missed today, that we didn't cover, a key point. So it can be a comment as opposed to a question, but let's keep it to like no more than sort of 2 minutes a piece. We don't want long speeches, but if there's anything that folks want to raise that hasn't been raised, and I guess this is your prompt from me as MC, that if you want to use the raised hand feature and say something audible, maybe identify yourself by name as well as your organizational affiliation. Folks seem to have been using the chat, which is great. It's been good all day. But again, just to give you the opportunity to make this as interactive as possible if there are any questions from the floor. So I will ask my ANSI colleagues to let me know if anyone has their hand raised.
No chats, Jim.
Okay. Let me circle back, and that invitation remains open. I mean, we do have a chunk of time here. We don't necessarily have to fill it, but when we had the planning committee call, there was a desire, it seemed, for folks to want to pipe up and just at least to kind of talk about where do we take this conversation from here. So that invitation will remain open. Well, okay, so let me see here. So I'm seeing some questions in the chat. Let me do this. I will just sort of read these aloud as they come in, and then I guess if any of the panelists would like to respond to them, I would leave that as an open invitation. So one comment is, I'm concerned that we're carrying too much of the old space mindset into the current discussions on STM. I don't know if there's any reactions to that. Let me read a couple first. There's another one. What is the status of activities in regards to the ANSI Space ISAC and SPD5? I can take a stab at that one. There's one, do the panelists think we have the right sufficient foreign policy institutions and tools to develop and collaborate on commercial space standards? Anybody interested in?
Hey, Jim, if I could make a comment on the first one briefly.
Go ahead, Dan.
Yeah, just to say, I think maybe, you know, Space Policy Directive 3, that's our national directive on space traffic management. That said, my experience in working with other U.S. People to assemble a proposal to focus on space traffic coordination and management met some resistance, and the primary international resistance was against our use of the M in STM. Because internationally, I think we're a lot further away from getting consensus on management, which implies enforcement, regulations, monitoring, and that sort of thing. So I think maybe one of the old mindset things is actually only a couple years old of us referring to this as space traffic management, which is an important part. But I think the first step is to get consensus on how we coordinate the space traffic, how we coordinate the SSA data, how we gather it, exchange it. So I just put that out there, that's a mindset that in our country, just in a couple of years, we've really kind of dug in and said, no, this is STM. And Ruth brought it up earlier, definitions do matter. But I think that's something we need to consider, is that if we want to get to the international stage and get the first phase of consensus, we need to maybe break these apart and think of space traffic coordination separately from space traffic management. Thanks.
Thanks, Dan. Anybody else have a perspective on that one they want to share?
Jim, I was going to go to the question on, sorry, it moved. Do panelists think we have the right sufficient foreign policy institutions?
Go ahead, Fred.
Okay. I think we do. I think we have the right, we do have the right organizations involved in establishing positions take into an international forum. And I'll give you an example of one of the things we've been working on recently, and it's, I think, a very impressive action is the confers activity, where DARPA said, hey, you know, this would be nice to go along with the technology development that we're showing. And industry got together in a consortium and decided what we wanted to take into a standards development organization. The consortium is international, of course, but largely U.S. And in developing those positions to take forward, we also had discussions with different government organizations. And so, you know, there's a lot of NASA involvement in some of those discussions, a little bit of touch base with DoD, of course. And so the short answer to the question is yes. The more interesting part of the question is, who are they and how do we interact? And I don't think that we really have rules set up for that. We just know that we want to have these different parties involved in our discussions, proper international introduction of concepts as we go forward, and harmonization of terms, and then the ability to be open in our discussions with those who are our competitors and our allies. That's my position on that one.
Let me just go ahead and respond to the one about the status of activities regarding the Space ISAC and SPD5. So some of you may recall ANSI released a request for information on behalf of the Space ISAC and the Aerospace Corporation in the context of SPD5, asking about space cybersecurity standards. We did get a very good response to that. Thank you to those who responded. We have provided the responses to the Space ISAC and the Aerospace Corporation for further review and analysis. I believe on the 9th of December, there is a meeting of a task group of the Space ISAC to kind of review those and determine next steps. So that is the current status of those.
So this is Jim. I have a sort of a separate topic, if I could bring it up.
Go ahead, Jim.
And that's sort of Fred Slane sort of hinted at it on our Confers Industry Association. And maybe this is for a future panel, but the incentive to our company joining that consortium, and actually maybe Jennifer Warren might have been more eloquent in saying this, our reason for joining that consortium was more defensive than it was looking to set standards. We were actually afraid that the standard setting organization was going to be counterproductive to the innovation that we saw bubbling in the new on-orbit servicing and new space arenas. That standards really hadn't had a chance to settle out yet. So we more went to join to protect our IP and to make sure that it didn't go in a bad direction that would hurt our profitability in the long run. As it turns out, it didn't. It was good. We were able to come up with very good broad level sort of rules of the road or operating principles and practices that stayed way above the specific IP issues, and so it was very beneficial. But I think on a future discussion, you should bring up those IP and profitability issues that are driving a lot of the new space companies, to look for creative ways to doing the space business. I'll stop there.
So there seem to be, thank you, Jim. There's just some comments. I think most of the panelists can see them about operators need to be responsible for SSA going forward. We need coordination between FAA and NASA to be streamlined and organized. There's a lot of folks wanting to comment on this idea of space traffic management, I guess, and how that is being addressed internationally. There's a comment that the FAA air traffic control model doesn't apply. There are multiple companies providing services, and transparency was stated as most important. So the question is, what is a future model for STM to avoid collisions for everybody? Someone else says, I'm not sure the concern about the management part is authentic. It could be a cover for other reasons, for resistance. And then there's a comment, there was concern in the EU about specific strong connotations of the term management. Some time ago, there was an SB report, they believe, that expressed the term coordination would be preferable for those reasons, and some of the reasons that Dan gave. The concept of coordination is related to that of management. The latter inherently raises questions about authority, but the current international and uncertain state of an STM/C framework is not forthcoming on authorities. Therefore, a more fundamental concept and activity is that of coordination, which arguably emphasizes cooperation more so. So a lot of focus on the terms that we use. I don't know if Dan or anybody else wants to have a further thought in reaction to some of those comments.
If I could, Jim, I tried to keep through these comments when they talk about the STM and ATM applying and the multiple operators, is that the focus, and this happens a lot, tends to narrow on this concept of collision avoidance between one or more maneuverable objects. And that's just a small part of the problem that we have in the orbital domain and where standards are necessary. So looking forward, and Danielle's space sustainability rating is a very important part of it, what do you have on board that can improve the quality of the environment, including time that you spend out of popular orbits. So it's a bigger picture than this sort of SSA collision avoidance that we need to look at, and that includes requirements to deorbit as well as the active debris removal, because the large part of our debris problem is not from a collision with one or more maneuverable objects. And a lot of risk going forward, and we've seen 2 near misses just in the last 12 months, are between 2 non-maneuverable objects that came within close proximity that could have created a significant debris field. So without looking at cleanup and deorbit, we're missing the big parts of the problem when we talk about space traffic management.
Thanks, Ruth.
Yeah, this is Dan, if I could. Yep. I agree that we need to look at all aspects of this, which is debris remediation, debris mitigation, and collision avoidance, those 3 legs, if you will, of space safety. I'm not sure I agree that space traffic coordination or management includes some of the debris remediation or mitigation things of design and so forth. I think that maybe falls out of what I would think of as space traffic management or space traffic coordination. I do want to circle back to Jeff Braxton's comment this morning, where he said that what the Air Force has been doing is space traffic coordination, not management. But you know, that is Ruth is right. That's in the smaller context of the bigger picture of how we get to space safety. I can say in the ISO and CCSTS arenas we're working, we are definitely focused on much more than just collision avoidance and SSA, but also the whole mitigation and remediation piece. Thanks.
So, you know, whatever we call it or whatever we end up calling it, I mean, I certainly was encouraged to hear this morning from Kevin O'Connell, you know, that Commerce will be involved in helping to, I guess, to push a new proposal along. And that kind of feeds nicely into the next question and was sort of prompted on the agenda. But the question that is asked here today is, can we create the plan of what are the key standards we would want to create, who should be involved, and what's the schedule to get those standards done, and the notation that it needs to be done in close coordination with NASA and FAA.
And Jim, if I could respond quickly, I would say the first step is exactly what you have assembled here. It's information exchange. Because at the start of this venue, this meeting, policymakers, top decision makers were talking about the need for standards. It's not clear to me that at the policy level, people know what already exists. So I think this forum here is very important because it gives us an opportunity to share standards that already exist, work items that are already in progress, and only then do we need to figure out, okay, those are going, but what more do we need? And then we can figure out how to staff that, to work it, and drive that to a finished, published standard. Over.
Thanks,
Jim, if I could just follow up with Dan, to point out that one of the other things that's come out of this discussion is where you can see where some of the places are where there's going to be more difficulty or less difficulty in coming to some of these agreements. That whole discussion about coordination versus management and where the resistance is again one of those things you can see in forums like this where you're going to have more difficulty, where you're going to have less difficulty, just from an organizational standpoint in getting people to agree on what to do. So again, another piece of useful insight there. Thanks.
Thanks, Marlon. I guess maybe asking it sort of another way, does anybody feel like we can sort of come out of today, and I know myself, I'll need to go back and sort of listen again, but any key standards, gaps, or opportunities that that jumped out at people as, we've heard quite a bit about STM, about the space sustainability rating, projects that are underway on large constellations, orbital debris mitigation, anything that resonated with any of the panelists in terms of like a key takeaway in that regard.
I'll take a stab at it. This is Dan. Consider that today to have a product that reflects the positional predictions, the positional knowledge of the estimated current population, that product takes 12 gigabytes to share uncompressed. And we estimate that when we have tracking upgrades that might track potentially 10 times more objects than they do today, that grows to 120 gigabytes. And then that information does not include error estimates, which would probably at least double the size of the product. So one forward prediction of data products, it could easily come to 250 gigabytes for one delivery. So kind of what I'm leading up to is, I think we are now really coming to appreciate the importance of data exchange, but I think there's a lot of work we can do to further make data exchange more easy for the operators and the SSA providers to do. And I would say that while there's a lot of good work in that, and we're working that, there's a lot more to do. Thanks.
Thank you, Dan. Just want to circle back again. Any of the panelists who are still with us, if there's anything that you sort of picked up on as something that you would want to reemphasize as a key point from today, especially those who were maybe on earlier in the day, if you're still with us.
Tim, this is George Neal, if I could weigh in.
Please, George.
So some great discussions today. Trying to step back a minute and see what we're learning and what the key issues are. It's not clear to me that the absence of a particular standard is the top priority issue now. Rather, I would offer that we're hearing consistent themes of it's time for action, and we need transparency. The data that we do share needs to be actionable, and we need to operationalize policies and procedures and so forth. So how do we get started? I think, frankly, the missing piece is a coordinated and blessed government focal point from the U.S., and whether that's Commerce, as the Space Policy Directive states, or not, they don't have yet the resources, authorities, immunities that they need from Congress in order to move out. So we need the U.S. government to come to a conclusion on this so that they can engage more efficiently with the rest of the community who are doing some great work out there. But even though there are a lot of people in government that are trying to do their part, it's not yet coordinated as a whole of government, whole of nation, whole of global space community that we can get to and that we need to get to once we know where the focal points are and who can coordinate all the many players who are interested in this very complex subject. So maybe with the new administration and the Congress, all of us can ensure that there's appreciation for the importance of this issue, and we can get a new gear in terms of what the government role is and what the responsibilities are of the various players so that we can all work together in an efficient fashion. Over.
Thank you, George. We do have Gradomir Radovanovic, who has his hand raised. I guess, I don't know if your question's been answered, Gradomir. Michelle, if you were able to unmute him, go ahead.
He's unmuted.
Hi, Jim. I'd just like to add to the previous discussions. Streamlining is required, but to have the streamline and good coordination, we have to define the specific set of goals. These are the goals. For those goals, this is the organizational support we need, this is the financial support we need, and this is the plan to which we're going to stick when we are going to work on those goals and get them done. So lots of things are done, and I heard that earlier this morning and now in a different pieces, in a different organizations, in a different ways, and maybe defining the goals. So we want to make the standards, for communication or avoidance or flight controls or safety, even though I see the FAA is doing lots of on safety side, and coordinate that with NASA, because I know NASA is already doing some of those standards and FAAs. Then we would easier streamline, get the players to join and get the budget to get it done if necessary. As long as we are just talking generic problems, and that's what I heard most of the discussions here are, because the people are just sticking with their problems. We don't have a goal. We don't have the plan. We don't have a realization. We don't have a schedule. And I'm sorry, but I'm a simple engineer, and as simple engineers, that's how I think.
Thank you very much. I'll invite if anyone on the panel wants to respond to that. If you have any feedback. Okay, I'm just having a look here because I thought there might be a couple people who might have a particular desire to speak about a particular point. One thing I'll mention as we're doing this, we do at when we do end the event, and it seems like maybe people are getting a little fatigued. It is late in the day here, at least on the East Coast, but we will have a very short survey that folks can fill out to provide your further thoughts. Are there other questions, other folks who would like to speak who have not already said something?
Jim, this is George Neal again. One other thought as we think about, what are the next steps and who can do what in a way that helps all. Circling back to J.C. Liu's presentation this morning, NASA clearly has a lot of expertise and capability on the research side for this. And that is something that really isn't practical for the most part in private industry as much as it is at least to guide the effort from the government. NASA has no interest in being the regulator for this area, but they have so much to contribute in terms of both characterizing the environment and helping the entire community understand what practices might help us going forward. And so again, even though they might not be right in the middle of some of these regulatory issues, they have a lot of capability that we have to make sure that they can be included in the overall effort.
Absolutely. One of the other things that I guess it's one of the questions we ask in the survey, but if we have a little bit of time here, should folks want to weigh in, is there interest in holding more of these meetings? And if so, what topics would people want to see covered? So another information sharing type of event related to the commercial space, the growth of the commercial space industry. Whether that's an attendee or a panelist, if anyone has a view they would like to share, we'd certainly invite that. Let me see here, getting some feedback on chat. So I'm seeing a yes on more events if they're more highly targeted and shorter time frame. Okay, and we'll take all of the feedback that we get today certainly into consideration and planning. So there is also, again, the questions about the SPD5 and cybersecurity standards being suggested as a possible activity. There's a comment to the effect of standards that an operator may choose or want to employ for mission assurance and financial sustainment may be quite different from what a country wants to adopt from a sustainability perspective. That can get lost in the standards discussion. Is there interest in, for example, the human spaceflight practices? I mean, that seems to be like a whole nother safety-related area that was kind of, we didn't really touch on today. Obviously, launch safety, there are spaceports, there's a whole lot of stuff that we didn't really cover, but so at least I'll put that in the mill for people to think about, if that would be something that might be of interest.
Jim, this is Vladimir again. Can we, for next meeting, call in FAA and NASA and get their inputs, what they think are high priorities, where we can jump in, and how we can coordinate between NASA research capabilities and FAA practical needs for operations, and then converge with the results that will be fairly well defined.
Right. So of course we did have we have lots of NASA folks on the line as attendees, and we had J.C. Liu, talking about the orbital debris aspects specifically. But we will take, as I said, all suggestions under advisement. There's a suggestion here that a next step might be to have a smaller committee kind of look at different elements that could sort of lead to more maybe coordinated planning. Maybe something on a smaller scale than an information sharing event like this to supplement this, I gather, is what I'm taking away. Looking at, specific standards and organizations that are dealing with those and when they might be developed. I mean, I think the point, I think it was it Marlon or Fred, whoever made it towards the end about participation, and if you have questions, if there's any confusion in your mind about where to participate, if something resonated with you today, you can certainly let ANSI know, and we can put you in touch with folks in terms of how to participate. Okay, getting some good feedback. There's, I guess, on the security elements, there's some feedback of the need to, as Colonel Hernandez mentioned, regarding operational practices that signal intent on orbit to help distinguish hostile versus non-hostile intent. Another good discussion is how to address actively controlled satellites who are signaled as a potential conjunction, a TCAS for space vehicles. What's the scope of STM? Are there other layers of standardization, SSA, debris? Yeah. There's also a suggestion on the government side of things that there really could be a whole government team addressing things from their perspective. So lots of thought starters. I'll do one last go around if there's anybody, audience member or panelist who wishes to to add any final thoughts. And again, I will extend my thanks to all of you who panelists, moderators, speakers, as well as attendees. If you think of something afterwards, again, please shoot me an email. My contact details are here on the last slide.
Jim, just a final point from me.
Sure.
Yeah, I think for a lot of folks, it would be very educational to participate in a discussion on a specific standard and its development process. A lot of folks talk about standards but haven't participated in and been part of the discussion of what's going on there. And I think that might be an educational piece. Not sure how to execute that properly, but I would suggest that people try and figure out how to do that.
Yeah, that's a great point, Fred. And ANSI does have on, I think it's standardslearn.org, a dedicated web portal where there are actually some sort of online classes. We have various levels of classes that can kind of help educate the community on what's involved in developing standards, particularly American national standards that go through that process. We've got an intervention here, open invitation for people to participate in the ASTM F47 Committee on Commercial Spaceflight. I think the SDOs across the board are always welcome and invite new subject matter experts to participate in standard setting. So I think with that, we'll end a little bit early, give you 14 minutes back. Again, my thanks to everybody for participating today. Please reach out to us if you have other thoughts that you want to share. And if you would, just as I close out the event, just take a moment. I think it's 4 quick questions, anything we could do better or different next time around. So thank you very much. And with that, we'll call the meeting adjourned.